So in 7.7, we want to look at ways to approximate definite integrals. But the whole spirit of this section would be if I cannot find the antiderivative. So I'm going to write that. The spirit of section 7.7 is for when we cannot find the antiderivative. And I worded it like that because, you know what? My example is one where we could find the antiderivative. But I want one that's kind of easy enough to work that you can follow along and see what's going on in this section. And so that's why I call it the spirit here of the section. Now, there are 5 ways we could approximate a definite integral. There are 5 ways that we're covering. There are 5 ways to approximate a definite integral. And 2 of them you saw last semester, but I like to list them in the 5. And in fact, I got 3 categories. The first one is with rectangles. The area under the graph, I could approximate it with rectangles, add up the area of the rectangles, and get an approximation of the definite integral. And so we have left-hand rectangles. Maybe you might hear them left-in rectangles. We have right-hand rectangles or right-in rectangles. And we have midpoint rectangles. That's 3 of the 5 right there. 2 of them are from last semester. And then the second category, we could use, instead of rectangles, I could use trapezoids. And this is called the Trapezoidal Rule. Some of you were asking for last week, is the Trapezoidal Rule going to be on the test? I don't remember us covering that. No, but it might be on the next test. Okay, the third thing I could use parabolas. And in fact, if I use trapezoids, that's called the Trapezoidal Rule. If I use parabolas, that's called Simpson's Rule. And I'm going to kind of work some problems of each type for you. For this, I'm going to consider the graph of y equals x squared plus 3. Now, this is a nice looking parabola. This is one I could do the antiderivative of, but I like to show this one because it's easy enough to kind of work it out for students to get an understanding of what's going on. So I'm going to say this. Example, consider the graph of y equals x squared plus 3. And with these techniques, we're going to estimate, estimate the integral from 0 to 3 of x squared plus 3 dx. Now, just so I can kind of get an idea of how close my estimate is, I'm actually we're gonna go ahead and figure out what this integral is, okay? Because this This is a problem you don't need 7.74, but it's a problem where you can kind of wrap your head around what's going on in 7.7. So I will call it like this. For reference, let's evaluate the integral from 0 to 3 of x squared plus 3 dx. This could have been something from last semester. What do you do for this? Okay, antiderivative is x cubed over 3 plus 3x. We're going from 0 to 3. So that's going to be 3 cubed over 3 plus 3 times 3 minus 0 cubed over 3 plus 3 times 0. That last part gives me 0, but you got to kind of think about it because it doesn't always give you 0. This is 27 over 3 plus 9. So that's 9 plus 9. The actual answer is 18. But we are going to estimate it using these 5 techniques.